Okay, we got Todd Brinkman here talking about human-wildlife interactions in Alaska. We're running a little bit late on time, but nobody has any lectures before quarter past two. But you use your the time you got. Even though the roast did go a little bit over.
I will make it fast to respect everybody's time, and then you can ask questions if you want me to clarify. All right, so the goals of this last part is I'm going to just highlight a few important human wildlife issues of concern in Alaska, especially those that I've been involved in. And I'm going to describe, just give you an overview of the type of research that we're conducting to try to address them. So when you think about the type of human wildlife issues that we study, you can put it in these two big categories, which are, you got the non-consumptive issues where people are interacting with wildlife to watch them, to view them. Or conflicts that might be a vehicle hitting a moose or a bear coming into the city, but the goal is not to harvest and eat it, right? And then the other part is that you need to talk about when we talk about Alaska, and I this is similar, I think, for Norway. We've got to talk about consumptive uses of our wildlife too, and that sort of human wildlife interaction. I'm going to begin up in the Arctic, okay, and then we're going to move south. As I'm sure many folks are aware, there's been a rapid decline in sea ice extent, 13% per decade since the late 70s, and the open water period now along the coast, especially of Alaska, is 36 days longer than it just was in the 1990s. And that's caused some changes in how our wildlife are behaving and how they're distributed on the land, especially things like polar bear. With that sea ice being so far off land, there's a greater proportion of the population now spending time in the terrestrial environment during the summer, and then also denning there in the winter. And this has created some opportunities. It created new opportunities for polar bear tourism in the area. In a couple of small communities on the North Slope, it has exploded. This is the little community of Kaktovik, where prior to the pandemic, the previous 10 years, you saw this explosion of boat-based tourism activities. However, with these polar bears spending more time on land, there's also greater opportunities for conflict. So the reason why so many polar bears are in Kaktovik is during the fall, they harvest bowhead whale. They bring the bowhead whale to shore, they butcher it, they distribute the meat throughout the community, and the carcass is left on the shore. You have this mass congregation of polar bear that come in and feed on this whale. The people come in, the tourists come in to watch it. But when you harvest this whale, you can see that as the blubber and the meat is distributed throughout the community, they basically just store it on tarps in front of their house. At the same time that there's somewhere around 60 bears in this little community of about 250 to 300 people. So you can imagine how there's opportunities for a conflict here or there. So the little picture in the middle is where a bowhead whales landed the day before. The chairs were there where the elders in the community were sitting and watching the bowhead whale be butchered. And then we came down there the next day, and there was a bunch of tourists around there, and we were monitoring things and beginning some of our research. The other sort of conflict that you're seeing more of now with polar bears. Yes. There is. I haven't interacted with him directly, but I'm aware that he has an operation, a lucrative one, at least it was before the pandemic. That's another story. It was shut down since then and it's not resumed. More polar bear on land. Of course, you have more opportunities for conflict with industry. Most of our oil and gas infrastructure in Alaska is on the north coast, and it's ever expanding. So there's also some concern about polar bears spending more time within that oil field complex. So with all this rapid change, it creates opportunity for important research. So these are just 3 of the projects that we're working on, and I'll just let you know a little bit about each. The one is the tourism operations in Kaktovik, that little town. They expanded so rapidly, the agency that was kind of monitoring that didn't have time to put together a tourism management plan, nor any data to support it. So we came in shortly after they realized that they were kind of had their hands tied. They needed to act quick. And we began collecting information on this boat-based tourist system, especially how bears were responding to human activity and also just how humans were behaving around the bears. The other project that we're working on was oil industry activity, especially now that there's a lot more bear dens onshore during the winter. So you got this field of snow, right? Snow is covering everything, snow and ice, and you have this equipment rolling over the top. They don't know if they're rolling over the top of a bear den necessarily because of how hidden they can be in the landscape. And then the other research project that we're working on is since the 1970s, when there was the kind of the explosion of oil activity on the North Slope, you started to see this increase in aircraft traffic, initially driven by agency or by industry, by government, and more recently by people like us flying around studying and also tourism. So you're seeing a lot more aircraft, and there's a lot of concern about the effects on the wildlife, but also the native communities up there. They don't like the idea of aircrafts flying over them while they're practicing their subsistence activities. So for the Bearden study, that was completed a couple years ago. There's my one of my students, Nils Peterson, his father came over from Norway. And what we did is we tried to optimize detection protocols. So how they have typically found both grizzly bear and polar bear dens up there is to use thermal infrared cameras on an aircraft. So a thermal infrared camera detects heat, right? So when these polar bears are in their den, a polar bear puts off about 120 watts of heat, roughly. A grizzly bear is about half that. That heat that they emit, even though they're hibernating, comes up through the snow, and we use our cameras to see that hot spot in the field of ice, okay? So what our study was doing is we attached it to drones so we could fly these over these bear dens, both the artificial that we created and live bear dens, several times to figure out what are optimal conditions for identifying these bear dens. So how it worked is we get on our drone, it was very cold, so the battery life went from like 30 minutes to 5 minutes, and we went old school and wrapped hand heating pads with duct tape around the battery to give us an extra 3 or 4 minutes. And you'd fly over and you'd look for these hot spots. Then you'd take that image back to the lab, you'd post-process it. And then if you weren't sure, you would often come back after the bear left for the year with that wonderful Carillion bear dog up there named Soledad to confirm that what we saw actually was a bear den. Sometimes we already knew and we just used this to monitor it. But the goal was to figure out when should you fly to optimize your ability to see that hot spot. And as you guess, do it when it's really cold. So there's a lot of contrast between the hot spot, the surrounding environment. Do it when there's not a lot of wind, which is erasing that hot spot. And then of course, as the season progresses, the thickness of the den gets deeper and it's more difficult to see the hot spot. The other more recent study we worked on is this aircraft disturbance. And for this, the regulators up there wanted to figure out, when we're flying over a polar bear, how high should that aircraft be to avoid a serious disturbance to that bear? This is another one of my grad students, Gwen Quigley. And what we did is we got in an aircraft, the one that you see right there. We flew up and down the coast looking for polar bear. Once we found a polar bear, we would start at roughly 500 meters and we would fly back and forth in a systematic way until the polar bear exhibited what is considered by regulators as a take response. So a take would be like an abrupt movement away from the plane. If it's nursing, it would be a cessation of nursing, breaking up a family group, flushing into water, things like that. So industry up there can only have so many takes a year before they get in trouble. So we were trying to figure out when takes were occurring with this aircraft. She's just drafting her manuscript, about to submit that, so I won't take away her wonderful results, but what we're trying to generate is this probability curve to see how the probability of take changes at these different elevations because of aircraft. Okay, before I leave the Arctic with you, I want to talk about another issue that's notable between human and wildlife up there, and that of course is caribou. We have 4 major caribou herds on the North Slope of Alaska, somewhere around 450 to 500,000 animals that fluctuates quite a bit. And since the 1970s, there's been concern over oil development and how it affects their distribution and their behavior on their calving grounds. This issue has escalated to of higher importance recently because of that orange little area over there, which is the Arctic National Wildlife Refuge, which is this kind of pristine, untouched landscape. During our previous administration, President Trump, I don't know if anyone has heard of him, he opened this area up for drilling. So we scrambled to get in there and get a bunch of baseline data in that area. If it was eventually opened up to oil and gas drilling, we could get pre and post information on the actual effects on caribou and other animals, which we did have in the Prudhoe Bay, which is the big oil complex in the middle. And what we're doing there is, of course, there's always been a lot of radio color work, but we have installed this massive grid of acoustic recorders and trail cameras. So the trail cameras are helping us get at distribution and occupancy, and the acoustic recorders are helping us get this soundscape data, which we currently don't have in that area. And how it works at each one of these sites, which there's 40, 20 in the Prudhoe Bay complex, 20 in Anwar. We have a trail camera running all summer, an acoustic recorder running all summer, recording a tremendous amount of data that's helping us better understand this environment from a unique perspective. And I'm fortunate to have Mega Para and Scott Leona, two other graduate students, helping me with this work. And it's going from 1999, well, geez, 2019 to 2023. Okay. So switching gears now to consumptive issues, which are important to talk about in Alaska. And the reason is because there's a lot of people that actively hunt. It's very important to the culture, to the nutrition, the diet, the people's diet, the economy. About 1 in 7 Alaskans is a licensed hunter, harvest around 7,000 moose a year, around 25,000 caribou, around 14,000 Sitka black-tailed deer. And I didn't put it up here, but fish, Dan, is so darn important. I gotta emphasize that. Tons of salmon, of course, is a big part of their diet as well. And if you get out of what are considered urban areas, and urban areas to someone that lives in Oslo is kind of a joke, what we consider urban areas in Alaska, but the dark gray areas would be your Fairbanks, the borough, the county around Fairbanks, your Anchorage kind of bowl area, and what is called the Matsu Valley, your capital Juneau down there in Southeast Alaska, and Ketchikan. Those are considered these urban areas. And then you have what are your rural areas, which are recognized by the state as these subsistence use areas. And in these rural areas, people are, of course, much more reliant on local wild foods because commercial goods are so expensive, for one, and also it's just part of their culture around there. So 86% of households in these rural areas consume subsistence foods, which are your wild game, fish, plants. And this is a graph of the per person consumption. I'm sorry, it's in pounds. Just divide by 2 roughly, and we got it in kilos. But it kind of shows that how, as you get more remote, so these areas here under the red line would be your areas on the road system and kind of those urban areas. And then you get off the road system, and the farther you get out, you can see how the per person consumption rapidly increases. Those top ones in the Arctic and the Western they're so high because there's a lot of access to, say, marine mammals, your ice seals, your whale. So that increases the amount of harvest that's brought in. But the point being, these wild foods are very important to these rural communities, and a reduction in the availability of the wild foods certainly can have a negative effect on overall community well-being. There's been several surveys recently that we've been a part of that just shows not just the harvest, the practice of harvesting wild foods, but the sharing of it. It trickles throughout the community and affects their mental, their social, their physical well-being. Okay, moving into interior Alaska, and I will cover this very rapidly. The big issue for hunting in there is concerns over climate change. Rapid climate change has been changing the availability of these resources that people rely on. The environment has been changing in all these different ways, and we've done a couple different studies that have looked at the specific conditions that are changing, where they're changing, and how they're affecting people's access. And through a lot of these focus group discussions and interviews, this is kind of the common theme that we get. The seasons are out of whack. The environmental cues that people used to use to safely traverse the environment are no longer working, especially during those shoulder seasons of freeze up and breakup. Right now, our research has shifted to actually try to quantify the effects of these environmental changes on harvest. One study we've completed was on moose, where we found major shifts in water levels can increase harvest or decrease harvest by 25%, and an increase in temperature during the fall can also decrease daily harvest by up to 7%. Lastly, Southeast Alaska, I wanted to give you a picture of the entire state. It's all about Sitka black-tailed deer. It's the most important subsistence and sport resource in that area. It's about the size of a roe deer, maybe a little bit bigger. And in this area is where we've had a boom in logging that began in the late 1950s and continued until just recently, when the last mill in the area is about to close. Here's your species. And what brought me to this research way back in 2003 was concern by rural communities that they weren't harvesting enough deer to meet their needs. And that was centered on Prince of Wales Island, third biggest island in the United States. It's on the southern tip of Alaska. And since the 1950s, there's been a tremendous amount of clear-cut logging that's taken place. So the forest, to give you an idea, it's a temperate coastal rainforest, big Sitka spruce, western hemlock, red and yellow cedar, all mixed in. Here's that island. It's one of the most productive areas in Alaska for logging, and 90% of the big timber has been removed. Your old growth forest. The yellow represents the roads that were put in there to support that logging activity. When I came to the island a long time ago, and I've continued this research today, is to understand the cause and extent of hunter difficulty through surveys, and then look at how changes in logging is affecting that deer population and hunters' access to it. So here's a cartoon for you. There's an old growth forest, okay, my depiction. We come in and we clear cut log it. We punch in a road to do so. Right after you log it, you've got this boom of vegetation. A lot of the forage that comes back are things that deer like. Well, it didn't take people long on the island to understand we got all this new access, these new logging roads with this open habitat with these deer. And they started utilizing these roads. And it was a wonderful time to be a deer hunter. All this new open landscape, good access with lots of animals, lots of forage. But we know that these young clear cuts don't stay young forever. So one of my first questions was to understand, how does hunting opportunity change as that forest grows? And what, according to 80 of the most active deer hunters on that island, the best hunting was when it's about 2 years old after the vegetation comes back. It's still good till 8 years, but at 12 years, 9 out of 10 of them said it's almost unhuntable. The other thing that we wanted to know is, how is this affecting deer? So when the stand regrows, they don't reseed it. It's natural regeneration. They don't thin it, at least early on. So you got this thick canopy, right, that the sunlight can't get through, and you lose all your understory vegetation. So we know then without that vegetation, that overall forest is probably supporting fewer deer. That carrying capacity on the island is declining. And we studied this. We looked at feces, super sexy work for about 3 years, where I was playing with deer pellets every day. And we used the DNA from that to estimate abundance in these different forest habitat types. And we found that, sure enough, these second growth stands were supporting about half as many deer as your unmanaged forest. So what the Forest Service, this is in the Tongass National Forest, the biggest forest in the US, they're stuck with these massive area of second growth forest now. What do we do with it? Well, what they're trying to do is get in there and thin to open up this canopy to create more forage for the deer, and also make the trees grow faster, so they might be able to get another harvest out of it. So you create this forage, and the idea is that these deer might come back. We're just beginning research on this to actually see how deer are responding to these thin areas. There's a lot of slash that remains. We don't know how deer are responding to it yet, but it looks like even when the vegetation comes back, deer are not able to access it very well unless managers do something with that slash. And I got 2 students looking into these issues. So thank you very much for your time.
Yeah. Thank you, Todd. Questions for Todd? Comments?